purpose of this video is to talk about factors that affect the rate of a chemical reaction. In every chemical reaction, we know bonds break, atoms rearrange, and then new bonds are formed. So breaking bonds is critical in a chemical reaction. Collision theory tells us that chemical reactions occur when the reactant particles collide with enough energy and also in the proper orientation so that chemical bonds can be broken. So if we have a faster rate of collisions, this will give us a faster reaction. The reactant particles colliding with each other more frequently would be a faster chemical reaction. We'll cover 4 factors that affect the rate of a chemical reaction: temperature, concentration, surface area, and the presence of a catalyst. At high temperature, particles are moving faster, and therefore they have more frequent collisions with each other. At lower temperatures, the reactant particles will move slower, and because they're moving slower, they have less frequent collisions. So because of this, at higher temperature, we have a faster reaction, and at low temperature, we have slower reactions. This is why a glow stick that is in cold water would have a slower reaction and not shine as brightly as one that is in hot water. However, because it is a slower reaction in cold water, that glow stick will also last longer. So if temperature is higher, the reaction rate will be faster, but if temperature is higher, the reaction time will be less because a faster reaction takes less time. When there are more reactant particles in a given volume, the solution has a higher concentration of that reactant. So here we see the 9 molar solution of hydrochloric acid has more reactant particles than the 1 molar solution. On the left, we see a high concentration of reactant particles, and because they are in a certain space, they are colliding relatively frequently because they are crowded in that space. On the right, we see a lower concentration. These reactant particles in the same amount of space are fewer particles, and so there are fewer collisions happening. So at a high concentration, we have faster reactions, and with a low concentration, we have slower reactions. If you were to dilute the vinegar that is reacting here, the vinegar would react much more slowly with the baking soda if it were diluted with water. Again, if concentration is greater, the reaction rate will be greater, but the time of the reaction would be less. Large particles have fewer exposed surfaces. If we take a large particle and crush it up or break it up into smaller pieces, grind it into a powder, it has smaller particles with more exposed surfaces. So say the large particle has less surface area and the smaller particles have greater surface area. In the diagram on the left, we see a large single particle, and there are not too many places that the reactant particles can be touching it or colliding with it at any given time. If we take that large particle and break it up into, say, 5 different pieces, as we've shown on the right, then there are more places for those reactant particles to be touching each other and colliding with each other at any given time. Here we see large pieces of chalk. They're reacting with vinegar, and they're reacting pretty slowly. If we would take those chalk pieces and crush them up into a powder, the reaction would be much faster, but also be over in a shorter amount of time. So to summarize, if the surface area is greater, the reaction rate will be faster, but if the surface area is greater, the reaction time would be less. A catalyst is any substance that increases the rate of reaction without itself being altered. Catalysts usually do this by lowering the activation energy that is required for a chemical reaction to occur. You may have heard of enzymes. Enzymes are catalysts. So to summarize, 4 factors that affect the rate of chemical reaction. Temperature. If we increase the temperature, it's going to give us a faster reaction. If we increase the concentration, it will also give us a faster reaction. If we increase the surface area by making the particles smaller, it will give us a faster reaction. And finally, in some cases, we can use a catalyst to make a faster reaction.